Hi, welcome to Custom Analysis using Raster Cell Iterator. This is Navajish Noman. I'm from Esri Redlands. Today, we're going to talk about the Raster Cell Iterator, or RCI in short, and neighborhood notations, followed by Raster Cell Iterator class. Then we're going to talk about how to create an empty raster, and then I will show you how to compute contour curvature, a custom analysis. Then we'll talk about additional resources that you can go to for further information. So what is the Raster Cell Iterator, or RCI in short? RCI allows you to visit each cell in a raster. If you have a raster, you know you have a lot of cells and you can actually go through them one by one. You can refer to a cell using its location by index in a raster object. The index starts from 0. You can read a cell value. You can assign a cell value. Well, if you want to assign a cell value, make sure your raster read-only property is set to false. Once you assign new value or update existing value, don't forget to save it using raster.save method. So what is the neighborhood notation? While visiting a cell, you can use relative indices to access the surrounding cell. We call them neighborhood notation. This capability is very useful for custom focal analysis. So for a cell at RC, you can actually refer to the cell of its left by using C-1. You can use C+1 to get the cell value on its right. You can use R-1 to get the cell value from top, and R+1 to get the cell value from bottom. As you can see, this is how I got all 9 cells value. So now let's iterate some cells in a raster. In this example, I have a small raster that has 9 rows and 9 columns. I want to iterate through each of these cells and print a few values. To do this, I have to import ArcPy and SA module. Once I got that, I will specify the data folder and the path to my raster. Make sure I got it right. So let's print the path and see I got it correctly. Now that I have my raster path specified, I'm going to create a raster object. Now, after I create this raster object, I also want to make sure the number of rows and columns are actually 9 by 9 and the cell size. One of the important things I'm checking here, the read only is set to true, which means I will not update this raster or will not be able to update this raster. I will just read the cell value. Now that I have got my raster, what I'm going to do is I will loop through this raster using R and C indices and get cell value. But instead of printing all of them, I'm going to print only every third of them. So let's do it. Once I run, I get this 9 value here. Let me double check. Let's turn on this. And as you can see, every third cells are highlighted here. And if you actually compare the value, it is exactly the same. So you can see this iterator not only looped through all cells, but actually printed the one I wanted to print. Now I will use the same raster to show you how to use neighborhood notation. So as like before, let's import ArcPy and SA module. Once I have it, let's specify the data folder and make sure I'm getting my raster path specified correctly. Then I will create a raster object and make sure it's the same raster within 9 rows and 9 columns, and also check the read-only property is set to true. Now let's see what I'm going to do when I iterate through these cells. I want to actually read the center cell here and its neighboring cells. So let's look at the iterator here. I'm looping through the raster, and where the row is equal to 4 and column is equal to 4, which is my center cell, I want to read the center cell value and then the column and the cell on the left and on the right. I can also read cells at the top and at the bottom. This way I'm going to read all 9 cells and print them. Let's do it. As you can see, it looped through very quickly and printed the 9 values that I'm looking for. Now I can compare with the values I have in the map 40, 40, 40, 40, and as you can see, the last one is 60, 60, 60, 60 here. So you can see how easy it is to use neighborhood notation to get the surrounding cell value when visiting a cell. Let's talk about the raster cell iterator class. What is it? It defines an iterator object to iterate through the cells of one or more rasters. It's an explicit iterator. It is very useful for iterating through multiple rasters while performing analysis using one or more inputs and creating one or more outputs. The raster key indicates the list of input and output rasters. The padding key lets you define a padding factor. It actually improves accessing the neighboring cells if you are using neighborhood notation. The skip no data lets you skip the no data cell automatically. Now this is very useful when you are processing raster representing discrete features like roads and river, where only few cells have value, most of them have no data. Now how do you create a new raster? The new raster will be created filled with no data, but how do you create it? You can create a new raster using raster object. However, your input has to be a raster info object. You can create an empty raster info object from scratch and set necessary properties like width, height, special reference, cell size, or you can get a raster info object from an existing raster using the getRasterInfo method and use it as a template. If you want to do that, please be sure to update the specific properties related to your new output, such as pixel type. Once you populate this raster with the cell values that you want, don't forget to save it. Now let's see raster cell iterator in action. Now I'm going to show you how to create a new raster and assign a new cell value to it. Now in this case, I'm going to create a gradual ramp. To do this, as usual, I have to import ArcPy and ArcPy SA module. However, I'm going to import math module also. Now, because I'm going to write a new output, I am also specifying the output environment to true so that I can override the raster if needed. I'm specifying my data folder as well as the output folder, specifying the input as well as specifying a name for the new output. Let's check and make sure that I got them right. It seems like I got my input and output right. Now let's create a raster object. Now as you can see, I am creating a raster object for my input and then getting the raster info from the input, the same raster I used before my 9x9 raster here, 9 rows, 9 columns. However, my output pixel type has to be float because I'm going to compute distance and elevation. So I'm setting the pixel type as float. and creating an empty raster object. I'm getting the cell size here because I will need that to compute distance. Now I am defining the raster cell iterator here. As you can see, I am actually specifying my input and output as a list of raster that I want to loop through. Then when I loop through, I'm computing elevation, which is same as the distance from the cell at 0, 0. That's the first cell. Then I'm assigning that value to the cell of the new raster. Let's do it. So the computation is completed. However, since I'm creating a new raster and writing cell value, I need to save it before I can use it. So let's save the raster. Now let's check in the output folder. I have got my new output here, and let me read it using the layer I have saved before so that you can see it. From the color ramp, you can see that it's the low elevation here at 0, 0, and as you going this direction, it's actually increasing. To be sure, we can actually create some contour and see the value, and as you can see, it's actually changing from 30 to 60 to 90 and gradually increasing in this direction. So we successfully created a new raster, which is the gradual ramp, using the raster cell iterator. I'm going to show you another example how to create a new raster. However, in this particular case, I'm going to skip no data cells while iterating through the raster. So I have actually a DM and a stream raster. Now in this stream raster, actually representing the distance from the stream center line going towards the bank. I'm going to use this not only to define my stream network, but also to calculate elevation. Now let's see how to do it. Now, like before, I have to import ArcPy and ArcPy SA module. So let's do it. Now, as before, I'm going to set override output to true so that I can override the output if necessary. As usual, I'm going to specify my data folder and the output folder and the input name and the output name. However, in this particular case, I have two inputs, the DM and the stream, and going to create one output. Let's check the path to make sure I've got all right. It seems all good. So now let's create raster object as before. Now obviously for two inputs, I'm going to create two raster object and get the raster info from one of them and create the output raster object. Again, I will set the pixel type because I'm dealing with floating point values here. Now I want to skip the no data cell. So what I want to do first, I want to understand how many cells I have in the stream raster with value or without value. So if I look at the number of rows, it tells me 384 and number of columns 593. So the total number of cells in that raster is 227,712. So of course you can understand that many of these cells are actually no data because this is my stream. So obviously other cells have no value. Those are the no data cell. Now let's define my raster cell iterator here. As you can see, I'm specifying input, stream, input, DM, and my output raster. But the most importantly, I'm saying skip no data from stream raster. Now let's see what happens. To check how many cells we are visiting, I'm actually setting a counter here to 0 and increasing the value as I visit each cell. Now, when I loop through these cells, what I'm doing, I'm actually calculating a new elevation by taking the elevation from the DM and then subtracting from the stream value. At the center, I'm actually lowering it by 60 feet. As I'm going towards the bank, I'm actually subtracting less so that towards the bank it is same as the elevation. So once I compute this information, I put it back to my output raster cell. And then this way I actually compute all the cell values along my stream network. Let's run it now. Now you see, it's actually visiting only 3,880 cells, which is much less than the total number of cells in the stream raster. So it tells you that the skip no data actually worked. Now that it is a new raster, as you know, you have to save it to persist the output. Now that I have the output persisted, let's go back and see, here's my output stream, and I can actually read it using the layer file I have already saved. Now as you can see, this is my new elevation of the stream bed, which is lower than the DM. This is why I'm saying I'm dredging the stream. Now that you have seen Raster Cell Iterator in action, let's do some custom analysis. Here we want to compute contour curvature using finite difference approximation. Contour curvature is a land surface parameter. As you can see from the formulas, that for a given cell to calculate contour curvature, you need not only the cell value of that cell, but you also need all surrounding cell values. We can get all the cells using neighborhood notation. Let's take a look at it. I'm using the same DM I used before to do this custom analysis. Now, like before, I have to import ArcPy and Esri module. Same as before, I'm specifying my input raster and output raster. I'm going to check the path to make sure I got everything right. In this section, I'm going to create raster object for my input and my output. Again, I'm setting the pixel type, otherwise it will not store the floating point value that I want. Now it seems like it has done it, so let me do some more calculation here. As you have seen in the formula, that I need cell size, I need the square of the cell size and the summation of the cell size. So I'm declaring this as a variable and computing it upfront so that my equation looks simpler further down. So you see, the cell size is 30, twice of cell size is 60, and the cell size square is 900. So I've got the information that I need. Now I'm going to declare my raster cell iterator with input and output. Now what I'm going to do is compute contour curvature. Looping through the cell using RCI here, and for each cell I am not only getting the cell value, which is Z5, I'm getting all the surrounding cell values Z1 through Z9. As you can see, the column number are changing, going left and right, and row number is changing, going up and down to get all the surrounding cell. Once we have all this 9 Z value, what we doing is calculating these terms that we have specified in our equation. After each of these terms are calculated, I'm going to check if my D value is too small. If it is true, then I'm going to specify 0 for the curvature. You can check in many different ways. This is the simplest way I have done here. Now, for the other cell where the D value is not very small, I'm going to calculate the contour curvature using this finite different approximation. Once that value is computed, I'm going to assign the cell value where I'm visiting correctly. So let's run it. So it computed and completed the computation, but you know already that I have to save it in order to use it. So let's go and save it. Let's look at the output folder again, and now I have my new out contour curvature.tif. That's the output I just created. Again, I'm going to use the layer file I have created before to take a look at the output. As you can see, it has created the contour curvature for this DM using this custom analysis and raster cell iterator. The most important and probably the fun part was the neighborhood notation, which let you look at top, bottom, left, right, and do the calculation as you are iterating through each cell. So the custom analysis become really easy to do using raster cell iterator. Now that you have seen raster cell iterator in action through various examples, you can check our online help for additional information. You can also check out our blog written by my colleagues to see more examples. Don't forget to send your feedback to us so that we know how we can improve and provide better content for you in the future. Thank you.